This is the Math 2 Honors Unit 12 review. And number 1 here says the graph is f of x equals negative x squared minus 9. Choose true or false. F of x is decreasing when x is greater than 0. And that's true. You can see that in the graph. Greater than 0, it is sloping downwards. The axis of symmetry is y equals 0. That's false. The axis of symmetry should be x equals 0. The maximum value of f of x is 9. That is true. Because you see this is up here at 9. The 2, 5 is a solution of f of x. Well, if we go to 2, 5, it appears like it's working. Let's just check it out with the equation. If I plug in a 2, you end up with negative 4 minus 9, which is negative 5, which is 5. So yes, true. Negative 1, 3 is a solution. That point is nowhere near our graph, so that's false. 3, 0 is an X-intercept. It appears that way. We could check. If I plug in 3, I'm going to get 0, so that's true. 0, 9 is an X-intercept. That's false. You can see that from the graph. And then the axis of symmetry is x equals 0. We established that already in part B, so that's true. F of x opens down because of the subtraction sign before the 9. That's not what makes it. It's actually the subtraction sign right here before the x squared. The vertex is at 0, 9. And that's true. The value of x when f reaches its maximum is 0, and that's true. Using f of x in number 1, determine the domain of f of x. So the domain is all real numbers. And the range is, well, the maximum is 9, so all y values less than or equal to 9. C says determine the rule for translating g of x equals x squared to f of x. Well, g of f equals x squared would be a parabola with a vertex at 0, 0, and it would be opening up. So two things need to happen here. We need to flip this upside down, and we need to move it up 9 spots. And so if we take our y values and flip them upside down, opens up. I want one more point of accuracy. I'm going to plug in 4 again. This time I get 1 plus 2, which is 3. So, something like that. And lastly, we have a vertex at negative 5. Negative 2 opens down. And I'm going to plug in negative 4. And I end up with 1 minus 2, which is negative 1. So something like that. For number 7, we want to state the axis of symmetry of each of the following. Well, if we can get the vertex, because this one's part A is in vertex form, we get -1, -3, and so the axis of symmetry share the same x value, so it's going to be x equals -1. Same thing in part B, vertex is -5, 7, so take the x value, x equals -5. That's the vertical line that cuts it in half, the axis of symmetry. Number 8, for each of the following is the ordered pair solution of this equation. So we just plug in the x value, see if we get the y value back. So if I plug in 0, I end up getting 1, so yes. If I plug in 2, I end up with -11, not 37, so no. If I plug in 2, I just did, I get -11, so that's yes. If I plug in 1, I get -2, so no. So yes, no, yes, no. Number 9, we have a graph. We're just to identify a few of these pieces. So the vertex we see is at 0, 5. The max or min value, in this case it's a max value, is at 5. The axis of symmetry is the line x equals 0 right down the middle here. Graph is increasing when x is less than or equal to 0 and decreasing when x is greater than or equal to 0. What is the transformation of the graph of f to g? And we compare them. They're both opening down. They both have the same width. What's different is the vertex. The vertex of the first one is at 0, 0. Vertex of the second one is at -4, -2. And so how do we get from 0, 0 to -4, -2? We translate left 4 units and down 2 units. And that's our transformation. Same deal here. Both f and g are opening up. They both have the same width. So all we have to worry about here is the translation. And so the vertex of the first one, 0, 0. The vertex of the second one is at 3, 1. And so we just need to think about how to go from 0, 0 to 3, 1. We translate right 3 units and up 1 unit. We have the graph of f of x below and the table for g of x. Which graph has a greater maximum value? Well, f has a maximum value at -2, where g has a maximum value at +3, so g. The value of x when g is at its maximum, that's 0, is greater than the value of x when f of x is at its maximum, which is at 3. So 0 bigger than 3? No. State the x-intercepts of g of x. X-intercepts have a y value of 0. And so if we look at g of x, I'm going to actually graph a little bit of g of x on our graph. so we have a visual. So the vertex is at 0, 3. And then the point negative 1, 2, and 1, 2. Then negative 2, negative 1, and 2, negative 1. So just look at that piece of the graph, and we're looking for the x-intercepts of g of x. Green one's g of x. So we can't tell exactly where those x-intercepts are. We know the one on the left is between negative 1 and negative 2, and the one on the right is between 1 and 2. And that's as specific as we can get, so that's what we're going to say. So between negative 2 and negative 1 is one of them, and the other one is between 1 and 2. State the zeros for g of x equals x squared minus 5x minus 14. Zeros are the same things as long as finding x-intercepts, finding roots, finding solutions. So we need to make g of x equal to 0 and solve for x. We can try by solving for by factoring at first, looking for two numbers a and b. If you multiply them together, you get negative 14, and if you add them together, you get negative 5. Well, 14 is 7 times 2, so if we go negative 7 and a positive 2, they multiply to negative 14, add to negative 5. So we could factor this to x minus 7 times x plus 2. And then set your factors equal to 0. And solve, and you get x is 7 and x is negative 2. A ball is thrown in the air and represented by this equation, where h is the height of the ball and t is time in seconds. Find the time it takes for the ball to reach its maximum height. So that deals with the vertex. And our vertex here is 3, 23, where 3 represents time and 23 represents the height. And so we're asked what time it takes to reach that height, so 3 seconds. For the above equation, what is the domain of this graph? Typically, out of context, a parabola would have a domain of all real numbers. But here we need to think, we're talking about time, and so the domain is going to be from, really all we're caring about here is how long the ball's in the air, so time needs to be greater than 0. Does it make sense to talk about, where's the ball after it lands? Sure. So we could say as long as time is greater than or equal to 0. How about the range? The range is definitely going to be, the maximum is 23 feet, so it's not going to go above that, but it's also not going to go below the ground, so it's not going to go below 0. So the range, the height, is going to stay between 0 and 23. So we need to restrict the domain and the range in this problem to fit the context of the problem. 15, we have a vertex at negative 1, negative 2. Domain is all real numbers. Range, well, if we sketch this, negative 1, negative 2, and we know that this thing is going to open down. So the range is all y values less than or equal to negative 2. And the axis of symmetry is the line cutting right down the middle at x equals negative 1. Our next graph, we're after the x-intercepts. the axis of symmetry, the vertex, and we want to graph this thing. So I'm going to see if it factors. So this is y equals, I'm looking for two numbers that multiply to negative 15, add to negative 2. So that would be x minus 5 times x plus 3. So from here we can get our x-intercepts at 5 and negative 3. And we could write 5, 0, negative 3, 0, because those are the actual points. I'm going to plot those. And then our axis of symmetry is right in between those points. So if we average those points, if we take 5 plus negative 3 and divide by 2, we end up with 2 over 2, which is 1. So that's my halfway mark at 1. So axis of symmetry is x equals 1. The vertex shares the same x value, so 1, and we need to find the y value. So I'm going to plug in 1 into our equation. Y equals 1 minus 5 times 1 plus 3, which is negative 4 times 4, which is negative 16. So this is going to drop way down to negative 16. And there we have it. 17. Again, I'm going to factor this. If it does factor, we end up with y equals x minus 5 times x plus 1. So my x-intercepts are at 5, 0 and negative 1, 0. If I find the mean of those numbers, 5 plus negative 1 over 2, we get 2. So 2 is my halfway mark. So my axis of symmetry is x equals 2. And my vertex is going to be 2 something. So I plug in 2 into one of those equations. And get negative 3 times 3, which is negative 9. Number 18 asks us to find the average rate of change. And we have two functions. So our first function is f of x equals x squared. And when you see average rate of change, think slope. Remember, slope is the change in your y values over the change in your x values. And here we're given our two x values. We're given 0 and 3. I'll go this direction. And we need to find our y values. Well, we have f of x is equal to x squared. So if I plug in 3 into that equation, I end up with 3 squared, which is 9. So that's my first y value. If I plug in 0, I get 0 squared, which is 0. So we end up with 9 over 3, which is 3. Same idea for part B, except we're working with function g. So g of 0 is 3 to the power of 0. Anything to the power of 0 is 1. And g of 3 is 3 to the power of 3, which is 27. So our slope is going to be, or average rate of change, will be 27 minus 1 over 3 minus 0, or 26 over 3. C says, how are the average rates of change different, and why are they different? So we can write, these are different kinds of functions. f of x is quadratic, and g of x is exponential. And then we can also make a comparison. The average rate of change for g of x is greater than the average for the average rate of change for f of x when x is 0 to x is 3. 19. A tennis player hits a ball with while standing on a platform. The path of the ball is modeled with the equation where x is the distance of the ball from the tennis player and f of x is the height of the ball. The ball starts at x equals 0. Based on the function, what is the height of the ball when it's first hit? So we plug in 0 into our function. Try to find out what f of 0 is. We get negative 0.02 times 0 minus 10 squared plus 21, which is negative 0.02 times 100 plus 21, which is negative 2 plus 21, and that is 19. And does it say that? Let's see. It doesn't state the units, so I'm just going to say 19 units. But actually, reading part B, we're talking feet, so we may want to say feet, 19 feet. Based on the function f of x, what is the height of the ball when the ball is 30 feet from the tennis player? So now we plug in 30. So f of 30 is negative 0.02 times 30 minus 10 squared plus 21, which is 20 squared plus, 20 squared is 400. And so that's going to give us negative 8 plus 21, which comes out to be 13 feet. Number 20 to 23, we're to find the zeros. Remember, zeros are the same thing as roots, or if they're real, they're X-intercepts, or sometimes we call them solutions. And so we have different methods here, and so the big thing is to decide what method we want to use. On 20, notice we're missing the middle term, the x term, and so I'm going to solve by taking the square root. I'm going to add 32 to both sides, divide by 2, and then take the square root. Remember to use plus or minus when you take the square root, and we end up with x is positive or negative 4. We could have also used solve by factoring on 20. 21, I'm going to also solve by taking the square root. I'm going to add 49 to both sides. Take the square root. Add 1. And then we need to split up into two cases. 1 plus 7 is 8. And 1 minus 7 is negative 6. 22. I'm going to use the same method. First by subtracting 50, second divide by -2, take the square root, and subtract 3. Split it up into two cases, and we get 2 and -8. 23 is different than the first three. We can't use solving by taking the square root. I'm going to check to see if this factors. I'm looking for two numbers, a and b, that multiply to -40 and add to -6. If we look at multiples of 40, we got 40 and 1. Let's just look at positive 40 right now. 20 and 2. 10 and 4, 8 and 5. And then asks, well, if I were to subtract any of these, would I get 6? Well, 10 and 4 would. And so then we're going to make 10 negative and 4 positive. So this factors to x minus 10 times x plus 4. Set your factors equal to 0 and get two answers. If x minus 10 is 0, we get x is 10. If x plus 4 is 0, we get x is -4. (24), we have an equation given to us. We're asked to find the x-intercepts, the line of symmetry, and the vertex. And it's given to us in standard form. So I'm going to go after the line of symmetry first. X is equal to -b over 2a, which is -4. Then I'm going to go after the vertex. We know the x value is the same, so -4, plug that in and find out what y is. We get 16 minus 32 minus 20, which is -36. Because I have, well, there's our vertex. For x-intercepts, I'm going to try to factor this thing. Set y equal to 0. Looking for two numbers that multiply to -20 and add to 8. Factors of 20 are 20 and 1, 10 and 2, 5 and 4. And if we subtract 10 and 2, we get 8. We want 10 to be positive, 2 to be negative. So this factors to x plus 10 times x minus 2. And so that gives us two answers. The x plus 10 gives us x is -10. And the x minus 2 gives us x is +2. So now we need to sketch the graph. We're going to have to hit as low as -36, so I'm going to go by 5s. So -5, -10, -20, -30, -40, and we'll go by 2s on the x-axis. So our vertex is at -4, -36, roughly right there. And our x-intercepts are at -10 and at +2. Something like that. And to be a little more accurate, our y-intercept is actually going through -20. 25 asks us to state the characteristics each equation reveals without changing the form of the equation. So if we look at 1a, or this the first equation, it's in vertex form, which gives us the maximum. The second one is in standard form, which is just going to give us the y-intercept, which is the value when x is 0. This is C. And the last one's in factored form, which gives us the x-intercepts, so that's B. Uh, 26 asks us to circle the letter of the equation below that will have no real solutions. So on this one, what I'm going to do is go to the quadratic formula. Quadratic formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a. And we're going to have no real solutions when we're taking a square root of a negative number. So it really comes down to the b squared minus 4ac. So if that is less than 0 or negative, then we know we have no real solutions. Otherwise, we're going to have real solutions. So that's what I'm going to do to check. So the first one, A, and we don't even have to work through the whole thing. So negative b squared, so that's negative 10 squared, minus 4 times a, which is 1, times c, which is 8. So here we're going to get positive 100 minus 4 times 8. That's still going to be positive, and so we don't want to circle that one. We're circling the ones that have no real solution. Part B, b squared. So b squared minus 4ac. So 12 squared is 144. And then notice we're going to have a double negative, so everything's going to be positive. So this is going to be greater than 0 as well. And so we're not going to take a square root of a negative when we plug this into the quadratic formula. Next one, we got b squared minus 4ac. This is 16 minus 84, which is negative, and so that is going to produce imaginary solutions. Part D, if we plug that into the, notice there's no middle term, so b is 0. So it would be b 0 squared minus 4ac. And we got this double negative with the negative 4 times the negative 36, which makes it positive, and so no worries about that one. The next one, we get 0 squared minus 4 times 1 times 4. That's going to give us a negative answer, so we'll have no real solutions on that one. And then F, we got negative 6 squared minus 4 times a times negative 7. That's going to give us positive 36 and positive 28, so this is positive all the way around, and so don't worry about that one. So C and E are the only two out of the 6 that produce no real solutions. 27a, what's the value of C such that, so we're asked here to complete the square. Remember, we take half of 10 and square it, which is 5 squared, which is 25. Same idea here, take negative 18, cut it in half and square it, which is negative 9 squared, which is positive 81. 28, we're simplifying, so we we distribute here and we get 6i squared minus 12i. And remember that I squared is equal to negative 1. So this is negative 6 minus 12i. D, we end up with 5i squared plus 4i, plus 20i. And I squared is negative 1, so this is negative 5 plus 20i. Part B, distribute. 2 times 3 is 6. 2 times negative 7i is negative 14i. Negative 15i and positive 35i squared. So that gives us 6 minus 29i minus 35 because I squared is negative 1. And 6 minus 35 is negative 29 minus 29i. E, we distribute, we get 8 minus 4i plus 18i minus 9i squared, which is 8 plus 14i. And negative 9 times negative 1 is positive 9. 8 plus 9 is 17. So 17 plus 14i. Part C. To simplify this, we can't end with an I in the denominator. Remember, I is defined as the square root of negative 1, and in previous lessons we learned that we don't end with a square root in the denominator. We want to rationalize it. And so we're going to multiply top and bottom by I. And we end up with 5i minus 2i squared over 3i squared. I squared is negative 1, so that's 5i plus 2 over negative 3. And we can leave it like that. If you were working on this through multiple choice, though, you may see it in a different form. Maybe someone multiplied top and bottom by a negative and maybe switch some terms around, so you can have negative 2 minus 5i over 3. They're the same thing. Both are acceptable. For F, multiply top and bottom by I. I squared is negative 1. And that's a good answer. 29. Solve by completing the square. This should be as equal to 0, and so then we can add 5 to both sides, and we get x squared minus 4x is equal to 5. Then we complete the square. Half of negative 4 squared is positive 4, so we add 4 to both sides of the equation, and then we factor. The left side factors to x minus 2 times x minus 2, but I'm going to write x minus 2 squared. Take the square root, you get x minus 2 is positive or negative square root of 9, which is 3. Add 2 to both sides, and we get x is 2 plus or minus 3, which is 5 or negative 1. Second one, or number 30. First step is to add 17 to both sides. Then complete the square. Negative 16 divided by 2 squared is positive 64. So add 64 to both sides. Factor. Factors to x minus 8 times x minus 8, or x minus 8 squared. And then add the 17 and 64, and get 81. Take the square root. Square root of 81 is 9, and add 8. So x is going to equal 8 plus 9, which is 17, and 8 minus 9, which is negative 1. Number 31, to find the vertex of the parabola. We first find the axis of symmetry by plugging in to the formula negative b over 2a. And I get negative 3. Negative 3 is your x value of your vertex. To find the y value, you plug negative 3 into our function. And we get 2. So our vertex is negative 3, 2. 32, we're going to approach the same way. And we get negative 6 for the y value, and x for the 1, or 1 for the x value. 33 and 34, we have equations in standard form that we want to write in vertex form. A couple ways we can do this. So method 1 is find the vertex like we did in 31 and 32. So our vertex is at 5, negative 24, and notice a is 1, so we can write f of x is 1 times x minus 5 squared minus 24. Method 2 is you can use completing the square to help you get into this form. Here's how. Start with the standard form. Complete the square by taking negative 10, cut it in half and square it, and we get 25. So if we have a positive 25, then we create a perfect square. So what I'm going to do is I'm going to write x squared minus 10x plus 25 minus 24. 25 minus 24 is still the 1 that I have here, but by putting the 25 there, I can now factor the first part to a perfect square. And it factors to x minus 5 squared, and I have it in the form that I want, and that's what I had before. 34, I'll do it both ways. Method 1, find the vertex. So vertex is 1, negative 6. So my function is going to be x minus 1 squared minus 6. Method 2. Start with the standard form. And take the negative 2, cut it in half, and square it, and you get 1. So what I want here is x squared minus 2x plus 1. But what I had is a negative 5. So 1 minus 6 is negative 5. Factor the first part. And we have it in the form we want. 35. I want to graph and state the solutions. For when f of x is equal to g of x. So if we graph f of x, we have a vertex at 0, 3, 0, negative 9. And it opens up. Something like this. Here's a little sketch of it. Not perfect, but that's our f of x. G of x is a line with the slope being 1, y-intercept is at negative 3. And we are looking for where they're equal to each other, so where the two graphs are crossing. It looks like at 2 spots. I'd say it looks like at x equals negative 2 and at x equals 3. We can check this algebraically if we set them equal to each other and solve. Let's set it equal to 0. Factor. Set each factor equal to 0 and solve. And I get x equals negative 2 and 3. So that verifies that my graph is good and that I can see where they're crossing. We're to label each as either linear, quadratic, or exponential. We're going to skip this part for right now, and we're going to learn this after the test. State all solutions. We can see where they're crossing. They're highlighted x equals negative 3 and x equals 2. Same idea here, x equals negative 3 and x equals 2. Solve for x, leave in radical form. It doesn't specify which method to use. You can use quadratic formula or completing the square. I'll do both methods. First, completing the square. To complete the square, you want to add add 4 to both sides. Because you take half of -4 and square it. Factor the left side. Take the square root of both sides and add 2. If we use the quadratic formula, you plug it in, so -b plus or minus the square root of b squared minus 4ac all over 2a. Simplify that 12 to 2 root 3 and then divide by 2. So we see that when you use the quadratic formula, you have a little more simplifying to do with radicals. 39 again, I'll solve both ways. First by completing the square. Take 4 divided by 2 and square it, you get 4, so you're going to add 4 to both sides. Factor the left side. Take the square root on both sides. Subtract 2. And because it's the square root of -3, we write I root 3. If you use the quadratic formula, it'll look like this. -b plus minus the square root of b squared minus 4ac all over 2 times a. It's going to be 16 minus 28. Which is -12. Square root of 12 is 2 root 3, but we have the negative, so it's going to be 2I root 3 over 2, and then divide by 2 to get -2 plus or minus I root 3. Number 40, we're simplifying. A is 2I. B is, 18 is 9 times 2. 9 is 3 times 3. So that's a perfect square. Square root of 9 is 3. It's negative, so I, and we're left with root 2. This is just I root 11. I times I is I squared, which is -1. 50 is 25 times 2. 25 is a perfect square, so this is 5I root 2. This is 3I. And square root of -1 is defined as I. 41, using the quadratic formula. -b plus or minus the square root of b squared minus 4ac all over 2a. And 37 is prime, so that would be our final answer. 42, let's skip. We will explore these things. This is linear regression and quadratic regression after the test. '43, rectangular chord is shown below. The walkway around its perimeter remains constant on all four sides. The court and walkway have a combined area of 130 meters. Write an equation to solve for the width. So if we let the width of the walkway be x, then the width of this large rectangle is going to be 10 plus 2x, and the length of the large rectangle is going to be 7 plus 2x. Definitely not drawn to scale, but there we have it. So the area is 10 plus 2x times 7 plus 2x, and that's equal to the combined area of 130, which is given in our equation, our problem. So go ahead and distribute. Combine like terms and rearrange the terms. And then I'm going to subtract 130 to make this equal to 0. All my numbers are even, so I'm going to divide them all by 2. And then I'm going to solve for x. Here I'm going to use the quadratic formula. So we get two answers, 3 over 2 and negative 10. But x represented the width of a walkway, so we're going to throw out the negative 10 because it doesn't make sense to have a negative width. And we're talking meters here, so this is 1.5 meters for our answer. Now this is solving by a quadratic formula, and you have some pretty big numbers in here. So you got to take like the square root of 529, you got to square 17. Let me show you what this would look like if we solve this by factoring. So we'd still start the same way, but at this stage here, we'd start to try to factor it. We'd look for two numbers that would multiply, so a times b, that would multiply to negative 60. So So multiplying 2 and negative 30, and add to positive 17. So 20 and negative 3 would work. So then we can factor to, well, before we factor, we could break it up. Factor the GCF out of the left side. We call it factoring by grouping. Factor out the x plus 10. X equals negative 10 and x equals 3 over 2. Notice this method, by factoring, we didn't have to work with such big numbers. And we throw out our negative, we still get our 3 over 2. I think easier. So it's always nice to check to see if you can factor something. It might turn out better.